Hello guys, welcome to Matrices 5. In the last class, we have seen some of the basic matrices operations like addition, subtraction, multiplication of matrices. In today's class, I'm going to take you through some of the properties of these matrix operations. My name is Srinivas and I'm here to take you through the basics of matrices. Right. So let's look at some of the properties of matrix operations. But before looking at these properties, first let us try to understand about the basic nature of these operations when we are dealing with simple numbers. I'm not talking about matrices here. I'm just trying to recollect your thoughts or recollect your ideas about the basic operations in numbers itself, simple real numbers. The first property is called as commutative property. Now, how many of you remember this? Take a second to think it. If you don't remember, no problem. This is what the commutative property holds for addition. The commutative property in addition talks about you changing the order of adding of things. Whether you add 3 plus 5 or 5 plus 3, it does not matter. So commutative property of addition is true. That is, when you change the order, it does not matter. This is about numbers. So once I make you recollect the basic properties for numbers, then we will see whether the same properties are valid for matrices or not. So I'm just going to spend the first 1 or 2 minutes trying to make you recollect the basic properties. Commutative property of multiplication. Here also you can see that whether you multiply 3 into 5 or 5 into 3, the answer does not change. So commutative property is true for multiplication also when it comes for real numbers. The next is associative property. How many of you remember what it is? Take a moment to think. If you don't remember, no problem. Let me show you what is the meaning of associative property. For addition, it is adding of 3 things. It does not matter which 2 things are getting added first. As you can see, 8 and 9 adding first does not matter even if 5 and 8 gets added first. The answer still remains the same. The answer still remains the same. What about associative property for multiplication? Even in multiplication, when you multiply 3 numbers, it does not matter which 2 numbers you are multiplying first. Because 5 into, first if you do 8 9s are 72, it is same as 5 8s are 40, 40 into 9. The answer is still the same. All this is true for real numbers. The last property is called distributive property. Do you remember what it is? Pause the video for a second if you want. Think about it. If you cannot or if you do not recollect, no problem. I have it here for you. The distributive property basically says when a multiplication is done over addition, then the multiplication gets distributed to both the numbers. So it becomes 6 into 8 and 6 into 10, the addition of these two. This is called as the distributive property. Okay, so we are going to see whether these properties are also valid for matrix operations of addition, subtraction, multiplication. So let's start with the first commutative property. Now commutative property tells you, just for you to remember, it is 3 plus 5 is equal to 5 plus 3. Does it also mean that A plus B for a matrix is same as B plus A? That is what we are trying to answer. Now you can see if this is matrix A and this is matrix B, addition of matrices, if you remember, basically it is addition of corresponding terms. So whether you add 1 plus 7 as the first or you add 7 plus 1, it does not matter. The final matrix will remain the same. So you can see that 5 plus 5 is 10, 6 minus 11 is minus 5, negative 5. Similarly, 5 plus 5 is 10 here, minus 11 plus 6 is negative 5. So you can see that whatever you fill here, it is same for both the things. So the commutative property of addition, it holds true for matrices. So you can interchange addition of matrices without a problem, right? Let's go ahead and take a look at multiplication, commutative property of multiplication. In terms of a number, it is 3 into 5 and 5 into 3. What about matrix? Can I multiply matrix A into B and then say, is it equal to or not equal to B into A? Let us try to understand. Now, if you remember, matrix multiplication is only possible if the number of columns in the first is equal to the number of rows in the second. If you interchange the order, this becomes 3 into 3 and 2 into 3, and you can notice that it may not even be possible for you to multiply. It may not even be possible for you to multiply. So definitely we can say that A into B is not equal to B into A for matrix multiplication, right? So the the commutative property of multiplication does not hold for matrices. Now you might ask, what happens if it is a 3 by 3 matrix you're multiplying? So let us say I have a 3 by 3 multiplied, this is A, multiplied with B 3 by 3. Now you might be wondering, what is the problem in this? B into A. Here there is no problem because you will get an answer both sides, left hand side and right hand side. In the example I showed, there is an answer here, there is no answer here. Here you might ask, there is an answer for both because 3 and 3 is matching. 3 and 3 is matching. But you will notice that it is always the first row multiplied with the first column. So when you do the multiplication on the left hand side, yes, you will get an answer. It may or may not be equal to the answer on the right hand side, right? It may or may not be equal to the answer on the right hand side because the first row here is getting multiplied with first column here, that is your first element. Whereas when you look at the other side, the row of the B matrix gets multiplied with the column of the A matrix and the numbers might not be same. So that is why definitely you can say that A into B does not be equal to B into A. At least the commutative property does not hold true. The commutative property does not hold true. Right? Let's move on to the next one. Associative property. Associative property is addition and the order of addition. Now logically, I think you can already make a guess because we saw that A plus B or B plus A, it does not matter. It also means that when you're looking at matrices, whether you add B plus C and then add it to A, or you add A and B and then add it to C, it does not matter. So the associative property holds true for a matrix. It holds true for a matrix. What about multiplication? Associative property of multiplication. It's very interesting. You might, some of you might think that A into B is not equal to B into A, correct? So you might be thinking that in this case also it will not be equal. You'll be surprised in this particular case that actually the associative property holds true for a matrix multiplication. So whether you multiply B and C first and then bring it to A, or you multiply A and B first and then multiply it with C, the answer will be the same. I'll show it to you with an example. Okay, I've given some simple numbers so that my time is not wasted in showing you this example. Now, if you remember the basic idea of multiplication we discussed, to not make mistakes, we make the rows here 2, 1, minus 2. Then you have 1, 2, 1, the first column, and 2, minus 1, and 1. So what happens here? 1 into 1, 1, plus 2 into 0 is 0. And so 1 into 1, plus 2 into 0, plus minus 1 into 1. Right? So what happens here? 1 into 2, plus 0 into minus 1, plus minus 1 into 1. Similarly, I write the numbers here very quickly. 2 into 1, 1 into 2, minus 2 into 1. And then 2 into 2, plus 1 into minus 1, plus minus 2 into 1. So here the multiplication becomes 0, 2 minus 1 is 1. 2 plus 2, 4. 4 minus 2 is 2. And 4 minus 3 is 1. This is your first answer, first part. This is getting multiplied with 1, 2, minus 2, 0, 1, 1. If you quickly do this, what do you get? Let's do this on the right hand side. It's a revision for you also. So 0, 1, 2, 1. Correct? Then you have 1, 0. Then you have 2, 1. Then you have minus 2, 1. Now here it becomes 0. And 0 into 2 is 0. 1 into 1 is 1. And then you have 1 into 1 is 1, because 0 again doesn't make any difference. So 2 into 1 is 2, 1 into 0 is 0, 2 2s are 4 plus 1, 5, minus 2 and 2, minus 4 plus 1, minus 3. So the matrix here becomes, the left hand side becomes 0, 1, 1. So left hand side, let me write it on the left hand side. 0, 1, 1, 2, 5, negative 3. This is your answer, left hand side. Let us very quickly look at right hand side, what happens. Okay, I'll very quickly do this just for you to understand that the associative property of multiplication holds true. So I'm just erasing all this. Right, so very quickly let's finish this right hand side. So what am I supposed to do here? I'm supposed to multiply these two first. So I will again draw this 1, 2, 2, minus 1, 1, 1. And I have 1, 0, 2, 1, minus 2, 1. So this becomes 1, 2 ones are 2 plus 2 ones are 2, 4, minus 2 plus 2 is 0. 2 ones are 2, 2 2s are 4, minus 1, 3. And 2 minus 2 minus 1. So minus 4, sorry, minus 1, minus 5. Then you have 1 ones are 1, 2 ones are 2 plus 1, 3, minus 2 and plus 1, minus 1. So this is the matrix. Now what do you want? You have, once more, you want to multiply this with this matrix over here. Correct? So quickly write down what you have. 1, 0, negative 1, 2, 1, negative 2. Then you have 1, 2, 1, 4, 3, 3, 0, negative 5, negative 1. Right? So let me quickly write it down. 1 ones are 1 minus 1 ones are 1 again. So this is 0. 4 ones are 4 and 3 into minus 1 is minus 3. So it is 1. 0, 0 and minus into minus 1 is plus 1. You can see 0, 1, 1 is matching. Next, 2 ones are 2 plus 2 ones are 2. 4 minus 2 into 1, 2. So 4 minus 2 is 2. 4 2s are 8 plus 3. 8 plus 3 is 11. 11 minus 6. 11 minus 6 is 5. And the next one is negative 5, positive 2. It is negative 3. So you can clearly see the right hand side is the same number. So this property holds true, right? Fine, let's move on. Next, the last thing is distributive property. Now, distributive property for matrix multiplication also holds true. It means whether you add the matrices first and then multiply it with A, or you break it up as A into B and A into C, the answer does not change. So the distributive property holds true for matrix operations, right? Now, please keep one small thing in mind. When you are multiplying, A comes first, then B comes. So you have to make sure that the order is not changed. You cannot write it as B into A, because here, when you are multiplying, A is first, B is second. Similarly, A is first and C is second. Similarly, if A is on the right hand side initially, then B comes first, then A. C comes first, then A. Unlike in numbers, you can write this as 8 into 6 plus 10 into 6, correct? But in a matrix, you cannot change the order, because I already told you, A into B is not equal to B into A. So you have to make sure that when you're distributing multiplication over addition, the order of the matrices is not changed, else you will be making a mistake. Okay, so that's all for properties of matrix operations, friends. In the next session, we will be taking up some really interesting topics. Till then, have a good day or a good night.